All right, welcome back. So in the first two videos, we understood the definitions of extrema and relative extrema. And for finding relative extrema, we learned how crucial to know the critical numbers or critical points of a function on an open interval. In fact, we're going to use this skill towards finding extrema on a closed interval. So let me just provide you the guidelines right away. Let's say like we start with the function on a closed interval a and b. The first task is in fact about the second learning objective, finding the critical numbers of f on the open interval a and b. So we're going to work with f prime. Either it's going to be 0 or undefined. Okay, so we're going to find those points and call them critical numbers. And we're going to evaluate f at each critical number. So in the first step, we're going to have a list of critical numbers. And what we're going to do is just function evaluation in the second step at the critical points. Okay, check mark, check mark. And also, endpoints are crucial because we have a closed interval to work with, because f may achieve extreme values at the endpoint. So we're going to evaluate also at each endpoint and b. Okay, so we're going to have function evaluation at the critical numbers as well as the endpoints. And the least of these values is the minimum, and the greatest is the maximum. So again, everything boils down to finding the critical numbers of the function, and then the rest is function evaluation and picking the least and the greatest numbers. All right, let's go with an example and try to apply 4 steps in the guidelines for finding extrema on a closed interval, -1 and 2 for the function 3 times x to the fourth minus 4 times x cubed. Our first task is to spot critical numbers, and we need f prime for that purpose. So we're going to write the original function and take the derivative of that using the rules that we learned in chapter 3. In fact, only power rule is enough to find the derivative of f. So it's 12x cubed minus 12x squared. So in the next step, we're going to either find x's for which f prime is 0 or x's for which f prime undefined. All right, let's set f prime to 0. Let's do this part together. So I'm going to pull out x squared, and in fact 12x squared. So this would be x minus 1 equals 0. Factoring out is really important to find the zeros here. So we have two zeros. One zero is x equals 0. The other one is x equals 1. And these are critical numbers. Critical numbers of the first kind, which are the ones that make f prime 0. So now the question is like, is there any x that makes f prime not defined? Okay, so f prime is here. Is there any x that makes f prime undefined? Or in other words, is there any number which is not in the domain of f prime? Well, f prime is defined everywhere. It's just a polynomial function. It's as nice as it could be, right? So there's no point that makes f prime undefined. So it boils down to only two critical numbers. One is x equals 0, and the other one is x equals 1. Also, we have to check that if those numbers are in the open interval -1 and 2. In fact, they are, so we keep them. We do have endpoints as well, right? Part of the deal was in the guidelines that finding the critical numbers and also listing down the endpoints as well. So in the next step, we are going to look at function evaluation at the critical points as well as the endpoints. Here we go. So we're going to look at the function value at the left endpoint, critical number, another critical number, and the right endpoint. So as you see that at -1, it takes the value of 7. At 0, it takes the value of 0, right? And -1 and 16 at 1 and 2. So we are going to take the greatest and least values here. So in fact, let me just clean this up. So in fact, so -1 is the least of all, and 16 is the greatest of all. So we have a maximum and a minimum achieved at the point x equals 2 and x equals 1 respectively. And now please have your calculators ready to graph the given function. and the graph of 3x to the fourth minus 4x cubed on the interval -1 and 2 closed should be looking like that. And you can just set your x min to be -1, x max to be 2 as you graph. And I want you to see this full picture in your calculator. And we can easily observe that at the end point here, a maximum is achieved. At x equals 1, the minimum is achieved. Here, there's one remark that I want you to see, that x equals 0 is a critical number, but there's no minimum or maximum. So here the catch is that you may have multiple critical points, and not every one of them spits out a minimum or maximum value. Just pay attention to that. But if there's a minimum at an interior point, so that is supposed to be a critical number. And we do know that for functions defined on the closed interval, maximum or minimum can happen at the endpoints. Endpoints are not critical numbers, but if, again, maximum or minimum is happening at an interior point, that point has to be a critical number. But not every critical number is going to spit out a maximum or minimum value. I hope I was able to get the idea across. So make sure that critical points are very crucial. And in fact, for the rest of the chapter, not only for this section, but for the rest of the chapter, you will see that we're going to use critical points extensively. Now it's the best time to practice the content. So we have the recitation videos available for you, and you have lots of cool examples here. As you see, that rational function and a radical type function, and you have a rational function. You're asked to find the critical points, and finding the extrema of an absolute value type function. So you have the sharp edges at certain points, and you're given a closed interval as well. So we're going to find the critical points, check the endpoints, and so on. And in the last one, you have a logarithmic type function, which is a non-trivial function, and apply the same process of finding absolute extrema on the closed interval. So please practice this content before you start the homework assignment. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.